Hi, this is Dr. Greg. I wanted to put together a quick video reviewing the tools and measurements that we will be using this year in science. So most of this should be review, so you should pick up on it pretty quickly. So let's get started. So when something is measured, we need to make sure that we use a number and a unit. 10 is not a measurement. 10 centimeters is a measurement. So make sure you have that unit on there. The second big thing that we need to remember is that we are always going to use the metric system in science. The metric system is used by most of the world today, and this is what we call the SI system. It's easy to use because it's based on this multiple of 10, and those prefixes tell you which multiple of 10 is being used. So if you remember, we talked about this with metric conversions. We've already kind of covered this. So this part here should be like, oh yeah, I totally know this. So if you don't, then you might want to revisit that video. Okay, so let's talk about the standard measurements we're going to use. Length. Length is basically how long something is. Your base unit for length is going to be meters, but you can have those prefixes added like centimeters, millimeters, kilometers, depending on how small and how big something is. The tools that we use for measuring length there are the ruler for smaller measurements, a meter stick for larger measurements, and a tape measure for really large measurements, like if you're going to measure a room. Some examples here is the length of a shoelace. You could easily do that with probably a ruler or a meter stick. And if you want to do plant growth like we did in the Wisconsin Fast Plans, you would use ruler. If you want to measure like the length of room, tape measure. All right, area. Area, you might remember this from math too, is the size of the surface of an object. To find that area, you just multiply the object's length by its width. Missing an apostrophe there. You know, it drives me crazy. The basic unit for this is meters squared. Because if we remember that meters is the basic unit of length, when we multiply length and meters times its width in meters, you get meters times meters, or meters squared. And if we have those prefixes there, or the smaller or bigger measurements, we can have centimeters squared, millimeters squared, and kilometers squared. Again, we're going to use the same tools: ruler, meter stick, tape measure. And to find area of things, you would do like area of a classroom. If you want to put a rug in a certain area in your room, you would need to know the area that you need to have it covered. Okay, so now let's go to another one you've probably heard, solid volume. So volume is the measurement of the amount of space something occupies, like how much space it takes up. So to find volume, we take the object's length times its width times its height. And so remember that our unit for length is meters, width is meters, height is meters. So we basically have meters times meters times meters. So we end up with the basic unit of meters cubed, meters to the third. Some other units that you will use: centimeters cubed or millimeters cubed. Again, the tools are the same: ruler, meter stick, measuring tape. If you were going to do solid volume, you would, like an example of this is how much space a box is going to take up in an area. For instance, liquid volume is the same thing, but we're measuring a liquid rather than a solid. So in this case, our basic unit is going to be liters. Other units, milliliters or kiloliters. In this case, we would have to utilize a graduated cylinder or a beaker or a measuring cup. We're going to talk about this in just a little bit here, but a graduated cylinder is always the most accurate way to measure a fluid. A beaker is less accurate. So if you need to have a precise measurement, use that graduated cylinder. Less accurate to kind of get you like an estimate, beaker. Example of liquid volume would be like how much soda is in a can, or how much liquid water you need to add to an experiment, or how much liquid of a chemical you need to add in there. One thing to note is that because of the fact that liquid volume and solid volume, they're both measuring volume, there is an interchange. And with that interchange right here is 1 centimeters cubed is equal to 1 milliliters. One thing to note is when you are measuring a liquid in a graduated cylinder, you're always going to measure at the bottom of the meniscus. When you put a fluid um, into the graduated cylinder, the fluid's going to come up on the sides and make this little curved area here. And so you always see this kind of arc. You need to make sure that you're measuring it right here at the bottom. This arc here is called the meniscus. And so we measure right here at the bottom. So in this case, our measurement would be 1, 2, 3. So 73. If you measured at the top, you would get more like 76. And so see, that's clearly very different measurements. So we always measure the bottom. Okay, next one is mass. Mass is how much matter is in an object. So this is going to be very different than weight. And we'll talk about the difference between mass and weight when we get to physics in the next unit. But mass, the base unit for that is grams. And so we can have those kilograms, milligrams, centigrams. We use the tools of a triple beam balance or a scale. Example where you would use it is like the mass of a pencil, or the mass of the object that we're going to calculate density with. So, or the mass of an amount of chemical that you need for an experiment. Again, weight is different because weight depends upon the location of the measurement. So weight is more, here's just a little preview, is that weight is going to be how the force of gravity is pulling on that mass. And that can change depending upon where you're at in the universe. Okay, so let's go next to temperature. Oh, look at that. I just kind of like skid all the way through that. Let's go back here. Temperature. Temperature is how hot or cold something is, so the amount of heat in an object. The basic unit for this is Kelvin. However, most scientists use Celsius, and we in America, in North America, use Fahrenheit. I think that's what they use in Canada too. I could be wrong. It may just be in the United States, but I thought it might be North America. So the tool we use is the thermometer. And so example, what's the temperature outside today? Do I need to wear a sweater when I go outside? Okay, so here's some example here. This is just kind of giving you a difference between the Celsius and the Fahrenheit scale. It's really cool with Celsius because it's set to where water is boiling, like pure water, pure H2O boils at 100 degrees Celsius, and then it freezes at 0 degrees Celsius. So it's kind of like a really great scale. But then when you go to Fahrenheit, it gets really wonky, and you get this 100 degrees is 212 degrees Fahrenheit, but 0 degrees is 32 degrees. So it's got this really weird conversion factor. But I'm not going to hold you accountable for that because we can always look that up. The other thing that we're going to talk about, the last type of measurement, is density. Density is the ratio of mass of a substance to the volume of the substance, or the amount of matter in a given space. I like to think of it as how much stuff is crammed into a given area. So if we have how much stuff, how much matter, that would be our mass in a given area, which would be our volume. So basically density is mass divided by volume, or density equals m over v. So if you memorize this equation, then you're going to be able to calculate all sorts of different things. So this is our big equation we're going to memorize. Density equals mass over volume. How much stuff is crammed into a space. We're going to be watching some videos and really delving into density here in a few more videos. So this is just a little slight preview. The units that here we're going to have is grams per centimeters cubed, or kilograms per liter. So they will also need to have a ruler or a measuring stick, whatever you need to measure your the volume. And you also have a triple beam or a scale to measure the mass. So examples of density is like the density of a solid cube, the density of objects to see if they're going to float or not. And again, we're going to delve into this in a lot more detail later on into other videos. Okay, so let's quickly go talk about one more thing of which tools are we going to use for measuring these. So these are we talked about the measurements and we talked briefly about the tools, but these ones you need to be able to identify the tool, know what they're used for, and be able to use them appropriately because we're going to use them a lot in the lab. Here we go. Beaker. A beaker, this is used to pour, mix, and roughly measure liquids. Remember, I said roughly measure. So you do see these graduations right here where you can be like, oh, this is about 200 mLs. However, if you really want that accuracy, you're going to want to use a graduated cylinder. An Erlenmeyer flask is this right here. You kind of got this conical shape here where it's like flat bottomed and it starts to come up like this, more like a cone, but then it levels out here. This is the Erlenmeyer flask, and we use it to pour and to mix liquids. It's not really used for measurements as much, but there are graduations here where you can roughly measure them, but it's not really very accurate. We use these a lot in chemistry experiments. Next, graduated cylinder. Here's our go-to whenever we want to measure volume. Again, those graduations right here are super accurate. So this is what we're going to use. There are a bunch of different sizes, 10 ml max, 20 mLs, tons of different sizes. The other one here, triple beam balance. This is what we use to measure the mass of an object. It's kind of like a scale, but it's different. You have these three different beams here, and you have to move them in order to balance them out. So we'll be using those two, and we'll revisit that, how to use it. So just be able to recognize that. And oh, no, we have three more. We have a ruler and meter stick here. They're used to precisely measure length. And then last, we have our thermometer, which is used to measure temperature. All right, well, that is it. Very quick, and it should probably be review. So, all right, thanks for watching. Be good, be kind, be awesome, and recycle.